Hey guys, welcome to your second flip lesson. Tonight's lesson is going to be on the volume of cones and the volume of spheres, and these are the last two figures that we have to find the volume of to get ready for our CUA. So this first one is a picture of a cone, and we want to know what the volume is. So over here on the side, we want to make sure we know what we're calculating, and what is it that we are calculating? Hopefully you said volume, and that's very important. And then we already know the name of this solid. It's a cone, which is listed right here in the problem. But before we can find the volume of the cone, we have to know what the formula is. So the formula for finding volume of a cone, you pay very close attention, is 1/3 pi r squared times h. So if you notice, this piece of the problem here should look familiar to you. Okay, and that piece right there is actually how we find the volume of a sphere. So we now know then that a cone, I'm sorry, I said a sphere, it's not a sphere, it's of a cylinder. We know that a volume of a cone is 1/3 the size of a cylinder with the same dimensions. So here we go, we're going to start getting ready to plug this in and see how it goes. Alright, so what is the base of this 3D figure? And I don't have the right choices over here, so don't look. We're looking over here. What is this base? Hopefully you said circle. And we already know that circles involve pi r squared times h at this point. The circle part involves that pi r squared. That's how we find the area of that circle. And the volume of this cone is going to include 1/3 of that volume of that area times the height. Alright, so let's plug everything into this formula that we have. Volume equals 1/3 times pi r squared times h. Those are the three pieces that we need to find the volume. So the first thing is identifying the radius, and this has a diameter here all the way across. It says that diameter is 8 kilometers, but we know that a radius is 1/2 of the diameter. So we're going to pick up this part right here. What is half of this diameter? And that would be 4 kilometers. So we know that our radius equals 4. So I'm going to go ahead and plug 4 in right here, and we're going to square that. We know we need pi. We know we need 1/3. And the last piece that we need is the height. That's from the point all the way down to the bottom of that circle. So that's that 9 kilometers right there. So the height of this is 9. And we're going to start plugging it in and solving it. So the first thing we do, order of operations here, is the exponents. 4 squared is 16 times 9 times pi. And then we've still got this times 1/3. And I want you to know now, before I go any further, that we can also say that this is pi times 16 times 9, which is this piece right here. And that whole thing is divided by 3, because multiplying by 1/3 is the same as dividing by 3. So sometimes it's a lot easier to do this type of problem here if you think about division instead of thinking about the fractions. So I'm going to continue working from this problem here. Alright, so the first thing I noticed to make my numbers simpler is I can go ahead and simplify this and say, okay, 9 divided by 3 actually gives me the number 3. So now I can multiply and say, okay, I have 16 times 3. 3 times 6 is 18. Carry the 1. 3 times 1 is 3 plus 1. I'm sorry. 4, that's 48. Takes too much time to erase. So this is 48. So 16 times 3 is 48. So now I have 48 pi, or times pi. Now there are two ways we can do this. We can read this in terms of pi, like we talked about with the cylinder, or we can approximate it and multiply that 48 times 3.14 to get a more definite decimal type answer. And you can do that if you like, but I'm going to go ahead and leave it in terms of pi because we want to get used to seeing it like this too. You're going to need that in high school math, and you're going to need it in trig especially. Alright, so let's move on. And I didn't give you any answer choices here, but again, I'm going to flip back to the screen one more time. We found out the volume is 48 pi, or 48 times 3.14. Okay? And one more thing that I want us to look at this evening is the volume of a sphere. okay? I didn't change any of the things on here at all, so we're not going to concern ourselves too much with what's on the side, but I'm going to show you how to work out a problem. And we're still working with volume, and volume of a sphere is equal to 4/3 pi r cubed. Okay, there is no height to worry about with a sphere. And in case you're wondering, a sphere is like a baseball or a basketball or those large bouncy balls that you find in big bins at Target and Walmart, things like that. Those are spheres. Okay, so a ball. The sun is a sphere. Earth is a sphere. All right, and this particular sphere has a diameter. Remember, what do we need to know? We have a radius, so we need to know that the diameter equals 2 times the radius, or half the diameter is equal to the radius. So what would be our radius in this case? Since we already know the diameter, the radius is going to be 5 centimeters. Okay? And we're not going to deal with surface area either. We want to actually know about the volume of that sphere. So we're talking about volume, not surface area. Okay? So we have 4/3 pi r cubed. The only thing that we don't know that we needed to know was that radius. We don't have a height to worry about, and now it's just a matter of plugging things in. So we have 4/3 times pi times that radius, which is 5. And this time it's cubed, and it's cubed because if we have a sphere that's a ball, pardon my drawing, this is how we show a sphere, and it's right here in the middle. This is a radius right here of that sphere. Up, across, or even sideways down here to the back. Those are all radiuses. So that very center of the ball. If you think about a baseball, for those of you boys, it's made out of cork in the middle. It's like the innermost piece of cork. Or if we're thinking about the earth, it's the core of the earth. That would be the very center of that sphere. Okay, so the first thing we have to do if we're working with order of operations is 5 cubed. So that is 5 times 5 times 5, a little exponent review. And this would be 25 times 5. And think about it, if we have 5 quarters, we have $1.25, so that's 125 if we multiply the whole number 25 times 5. So now we have 4/3 times pi times 125. Now, just like we did with the cone, we can do the same thing with the sphere. This is just like saying 4 pi times 125 all divided by 3. Okay? So I'm going to multiply my 125 times 4, and we're going to do this mentally. So if I think about the number 125 and I break it down, 100 times 4 would give me 400. Let's just go with 25. 25 times 4 would be another $1 or 100 if we think about that. So now we have 400 and we have 100. So this is going to be a total of 500 pi all divided by 3. Now, if you know your divisibility rules, you know that 500 is not evenly divisible by 3, so we would end up with a decimal. So we can actually leave our answer just like this, or we can continue to simplify it out. Okay? I hope that this has been helpful. Again, if you would like to use BrainPop, this is the same example. I'm going to try to get to a blank page. If you'd like to use BrainPop, you can go to BrainPop, and it's RMS 2012. Password is Warriors. And remember, that has to be before 7 p.m. Okay? I would like for you to take notes on this and have this ready as your ticket in the door in class tomorrow, and be prepared to do an activity with cones and spheres when you come in tomorrow. All right, have a great evening.